Hello, my name's Morris. I'm the developer of the CytoCave visualization tool. Welcome to my demo. Today we're examining the BRCA2 gene in the HuMAP2 protein interaction and complex database. In this visualization, cofractionation mass spectrometry data, CFMS, is depicted as a protein interaction graph grouping proteins into complexes. Well, CytoCave's central visual design is centered around the dual viewports, which support a range of analytical tasks, including comparative analysis of different datasets or detailed examination of specific clusters. Now, nodes are linked between the two views, so selecting or highlighting one in one view causes it to show up in the other. And this sync button up here synchronizes one view with the other. So if you get into a coordination that you can't get out of, you kind of use the other one as a bit of a lifeline. So one useful way to use the two views is to have one complex close-up examined in one view while the other view has a map of all the complexes. Now, up at the top we have the subject and coordinate system drop-downs. There's two subject dataset, ELUTE1 and ELUTE2. These are replicates, so we'd expect the graphs to be the same, but it's possible that the raw data may differ between the two. And also we have these coordinate systems, and they show different arrangements of the complexes. The straight arrangement is linear in this example. It's ideal for focusing the analysis on specific interactions. And then the square arrangement arranges these complexes into a 2D square, facilitating an easier comparison between multiple complexes and having it in this compact form. And the third one arranges them on the faces of a Platonic solid in 3D, which could be useful for navigating the complexes in VR. Let's let this back to square for now. Now, CytoCave includes a range of display customization controls. There's an interactive legend, which is used to manage the visibility of complexes. Clicking on a complex's representation in the legend once causes it to go dimmer, and clicking it twice causes it to disappear, and then the third time causes it to reappear. You can do that with any of these complexes, and it works in both views. Edge opacity slider allows for fine-tuning of protein interaction strength visualizations, which are visualized by the edge thickness. And there are these sliders down here for the sphere size, scaling. They're linked between the two views by default, but they can be unlocked to allow separate scaling control of the proteins representing spheres in each view independently. These are useful for visualization clarity and portability across devices like phones and tablets with various screen sizes. It also offers some enhanced analytical tools, like this interaction threshold can be set to focus on the more significant connections within the data set by eliminating the weaker protein interactions. If you set it too high, all the edges disappear. If you set it low, all the edges appear, but they're still displayed with edge width representing the interaction strength. The skybox can be toggled on and off with the skybox button. And this show line plots button here shows the raw evidence for the edge connection weights. So the edge connection weights are derived from the elution plots from the CFMS data. And clicking on the nodes shows the elution plots over here in the elution plot section. Now we have the elution 2 data on the left and the elution 1 data on the right. So clicking on even the same node on the left and right, the same gene, brings up the mass spec cofractionation data from the two different data sets so they can be compared. And finally, I'll demonstrate how VR can be used to browse this data set immersively. Click the Enter VR button. So it shows you the same view from the same angle as you were browsing in the 2D view on the web browser. And you can navigate with the controllers. The left controller, thumb pad, and the horizontal axis is controls the yaw from left to right. And forward and back accelerates you forward or back in the direction of whichever direction you're looking. The other controller's thumbstick controls your roll around the front back axis or your pitch around the horizontal left right axis. And the same as in your mouse controls in the web browser, you can click on nodes to select them, and if they have elution data, it'll display in the heads-up display over there. You can compare the elution cofractionation data amongst nodes that have that data. You can use the desktop, if you bring it into VR with you, as a palette. I'm about to make a real palette, but this will work for now. So you can do the same things you can do in the 2D display. You can control the skybox there. You can adjust the edge threshold. You can adjust the edge opacity. And you can interact with the legend to make complexes go dim, disappear, and reappear. As well as adjusting the node scaling. Also, the coordinate system can be changed within here. Set that to square or straight. And you can click the Exit VR button to go back to the 2D display. And also the color coding can be changed from the complex ID, which allows for each complex to get its own color, to another feature of the data set. So here, the confidence score for each complex in this data set is 5, so they're all blue, they're all one color. This is the highest it can be, but and if there are any lower confidence complexes, they would appear in a different color. So I'll set this back. Well, thank you for joining me with this demo. As you can see, the CytoCave's design, including the dual viewports and VR capabilities, supports a thorough examination of datasets catering to different research and browsing preferences. This flexibility enhances the overall understanding of protein interactions and complex formations within the dataset. Thank you for joining me.